Now let us look at entirely different aspects of current, that is the chemical effects of current. Essentially this is the topic known as electrochemistry, which you have discussed in your subject chemistry. All the process of electrolysis and all those things, they are essentially the part of it. So we are not expected to go too much into detail of that, rather just the Faraday's law of electrolysis and a simple basic formula. यहाँ पे हमें बहुत ज़्यादा डिटेल में ये सारी चीज़ें नहीं करनी है. You have already done that thing in chemistry. एक सिंपल Faraday's law of electrolysis की जो फॉर्मूला है उससे बेस्ड हमारी सारी डिस्कशन कंटिन्यूड होती है. Here let us first talk about the basic terms which you use. If you look at the basic terms, then we say what is the meaning of electrolysis. If let us suppose you have a container in which say sodium chloride solution is there and you have put two electrodes, you can take, say, if not sodium chloride, then copper sulfate, silver chloride, anything you can take. If let us suppose you have taken, say, silver chloride here, then it is said that it was the bonding between Ag plus and Cl minus. If you look at the physical aspect of the formation of the compound AgCl, it was the positive charge of silver and the negative charge of chlorine that was binding each other, and you have put this into a solution. आपने इसके बीच में कोई लिक्विड रखी है, so liquid is coming in between. और जैसा कि आपने इलेक्ट्रोस्टैटिक्स में पढ़ा था कि अगर दो चार्जेस के बीच में हम कोई डाइलेक्ट्रिक मीडियम डाल दें, in case you put some dielectric medium in between these two charges, then उनकी force of attraction less हो जाती है. Their force of attraction becomes less, and in that case इनके अपने ions में dissociate होने की tendency होती है. This is essentially happens whenever you are making a solution of ionic compound. They get dissociated into their ions, Ag plus Cl minus or Na plus Cl minus, or maybe it's a copper sulfate solution, then Cu double plus SO4 double minus. This is the kind of thing. So here in the process of electrolysis, you are essentially passing some current into an electrolyte. Electrolyte is another word you are using here. Electrolyte is the solution of that ionic compound. Here you have electrolyte, the entire thing. And the positive ions, they are called cations. You have anions, negative ions. On the similar line, you have anode and cathode. Cathode is the one which is connected to negative of the battery. Let us suppose here I have connected a battery like this. This is minus, this is plus. So this is called cathode, this is called anode. And the container which you have, that is called voltmeter. Mind the language, volta, A is present here. It is not voltmeter, it is voltmeter. Voltmeter is essentially the container. This container in which electrolysis process is taking place, this is called voltmeter. For example, they say silver voltmeter. That means in which essentially silver will be getting deposited. They say copper voltmeter, water voltmeter. That means the electrolyte will be involving those names. Now the process of Electrolysis is that you are passing some current into that. Now you see, in case this cathode is negatively charged, it will essentially be attracting positive ions. Here the Cl minus will have the tendency to move to positive side, Ag plus will have the tendency to move to negative side, and gradually this silver starts getting deposited here on the cathode, and you call it the process of electrolysis. You understand? Now, as I said that it is only the basic Faraday's law of electrolysis we are supposed to discuss here, then let us Faraday's laws of electrolysis. There are essentially two laws. The first law says that the mass deposited is proportional to the charge flown in the electrolyte. Here you saw the mechanism that if it is connected to negative charge, then silver plus ions, they are mixing with the electron here. You see, electrons are coming like this. These electrons are being released by this chloride ion. These electrons are coming here, and this electron is getting combined to this Ag plus. Since there is a movement of large amount of ions is involved, and ions, positive ions, they are very heavy, the motion is very slow and the process of electrolysis itself is very slow. Now this silver is getting deposited here. Then in case you have passed the current Q and mass M has been deposited, then it has been seen that the mass deposited, which I am denoting by M, that is proportional to the charge which is flowing in the process. अगर आप चार्ज फ्लोन डबल कर देंगे तो आप देखेंगे जितना मास डिपॉजिट हुआ है वो भी डबल हो गया, चाहे कोई भी मास डिपॉजिट हो रहा हो, चाहे वो सिल्वर डिपॉजिट हो रहा हो, चाहे वो कॉपर डिपॉजिट हो रहा है. अगर आपने करंट डबल किया तो मास डिपॉजिटेड भी डबल होगी, करंट हाफ कर दिया तो मास डिपॉजिटेड भी हाफ होगी. एंड सेकेंड लॉ सेज दैट आपके पास कई सारे डिफरेंट इलेक्ट्रोलिसिस के प्रोसेस हैं, कई सारे डिफरेंट वोल्टामीटर्स हैं, मे बी एक कॉपर का है और एक सिल्वर का है. दोनों में आपने अगर सेम करंट फ्लो किया, फॉर सेम करंट फ्लोन, फॉर सेम करंट फ्लोन और फॉर सेम करंट फ्लोन फॉर same time, or you can say for same charge flown, different voltameters में same charge flow किया आपने, then it has been observed that mass deposited is proportional to their gram equivalent, which you popularly denote by E. ये देखा गया है कि अगर आप चार्ज सेम फ्लो करा रहे हैं तो जो मास डिपॉजिटेड है वो उसके इक्विवेलेंट वेट के प्रोपोर्शनल में होता है. फॉर एग्जांपल सिल्वर का इक्विवेलेंट वेट आप 108 ले रहे हैं, कॉपर डबल प्लस आयंस के लिए 63.5 डिवाइडेड बाय 2 ले रहे हैं. ग्राम इक्विवेलेंट वेट इज व्हाट? The atomic weight, roughly you can say atomic weight divided by valency involved in that reaction. तो आप देखेंगे जो भी मास डिपॉजिटेड होता है वो उनके ग्राम इक्विवेलेंट वेट के प्रोपोर्शन में होता है. नाउ इफ यू कंबाइन these two equations combined can be written as M is equal to ZIT. Essentially this is the only equation on the basis of which दिस टॉपिक इज डिस्कस्ड. हम कहते हैं अगर इन दोनों इक्वेशन को आप कंबाइन कर दें तो दिस M इज इक्वल टू ZIT. in a combined manner, this equation is m is equal to zit, where z stands for, हम इसको ECE भी कहते हैं. ECE stands for electrochemical equivalent. Electrochemical equivalent. क्या मतलब है इसका? Its meaning is that अगर चार्ज 1 कूलम हो, this I into T is what? कूलम. अगर 1 कूलम चार्ज फ्लो करेंगे तो कितना मास डिपॉजिट होगा? m by q. This is the meaning of electrochemical equivalent. So if you see the unit of it, then kilogram per coulomb, or more commonly gram per coulomb may be the unit of this. Z का मतलब है कि अगर 1 coulomb of charge flow करेगा तो how much amount of mass is deposited, so that decides Z. So remember that in this particular topic, the formula you are using, that is simply m is equal to zit. Now on the basis of which, let us define another term which you call, what is the meaning of 1 Faraday of electricity? Now let us discuss what is the meaning of 1 Faraday of electricity. Meaning of 1 Faraday of electricity. One Faraday means, it is said that 1 Faraday, electricity means what? Charge. 1 Faraday of charge or electricity is required to deposit 1 gram equivalent of the substance. किसी भी सब्सटेंस की 1 ग्राम इक्विवेलेंट को डिपॉजिट करने के लिए जितनी इलेक्ट्रिसिटी चाहिए, दैट इज कॉल्ड 1 फैराडे ऑफ इलेक्ट्रिसिटी. इट्स एसेंशियली अ वेरी लार्ज यूनिट. अप्रॉक्सीमेटली हम कहते हैं इसकी वैल्यू 96500 कूलम के अराउंड आती है. वी से दैट इट्स वैल्यू कम्स अराउंड 96500 कूलम. नाउ लेट अस try to discuss why this value is coming out to be 96500 approximately. If you look at the mechanism of this, then you consider you had silver plus. Let us suppose you have a silver voltmeter in which silver plus ion is there, and 1 electron will be required to deposit 1 atom. I am trying to say 1 atom requires 1 electron. अगर आप सिल्वर का एक एटम कैथोड पे डिपॉजिट करना चाहते हैं तो 1 इलेक्ट्रॉन की जरूरत पड़ेगी. नाउ हाउ मेनी इलेक्ट्रॉन्स required for 1 mole of silver. अगर हम पूछे कि अगर 1 mole of silver है, 1 mole of silver का मतलब हो गया 6.023 into 10 to the power 23 silver atoms. Then if I am asking how many electrons are required for 1 mole of silver, then you will say so many electrons, isn't it? Here, since the valency of silver is 1, So these many atoms, whatever will be the weight, that is atomic weight as well as equivalent weight. So these many electrons are required to deposit 1 mole or 1 equivalent of silver, isn't it? If you calculate the charge value of this, how much charge involved, then it is simply 6.023 into 10 to the power 3. And what is electronic charge? Electronic charge is approximately 1.602 into 10 to the power minus 19 coulomb. You understand? And that comes out to be around 96500 coulomb. You get it? अगर आप सिल्वर का 1 मोल डिपॉजिट करेंगे तो 1 मोल इलेक्ट्रॉन्स चाहिए होंगे. वाई? बिकॉज इसकी वैलेंसी 1 है और 1 मोल ऑफ इलेक्ट्रॉन्स में इतने चार्ज होते हैं. 1 फैराडे ऑफ इलेक्ट्रिसिटी. अनदर मीनिंग ऑफ दिस थिंग इज दैट द चार्ज इन 1 मोल ऑफ इलेक्ट्रॉन्स. और अगर कॉपर डबल प्लस इन्वॉल्व होगी तो 2 मोल्स ऑफ इलेक्ट्रॉन्स चाहिए होंगे और 2 मोल्स में इसका डबल चार्ज हो जाएगा. अगर दोनों साइड 2 से डिवाइड करेंगे तो इधर 1 मोल आएगा, उधर 1 ग्राम इक्विवेलेंट हो जाएगी. 1 मोल ऑफ इलेक्ट्रॉन्स और उधर 1 ग्राम इक्विवेलेंट ऑफ कॉपर. हमेशा ये बात होगी कि 96500 कूलम विल बी रिक्वायर्ड to deposit 1 gram equivalent weight of the substance, and that is called 1 Faraday of electricity. The value is approximately 96500 coulomb. Now let us take a very simple example based on M is equal to ZIT. Let us take a numerical example on assume that for a particular current I flowing for time t 54 gram of silver is deposited. Assume that for a particular current I flowing for time t 54 gram of silver is deposited. Then how much amount of copper will be deposited from copper sulfate solution? This is your question. The question is saying that 54 gram of silver is being deposited for a particular current for a particular time. Then how much amount of copper is being deposited from this copper sulfate solution? Here the basic concept which is involved is that mass deposited is directly proportional to the gram equivalent. So you are using the concept that mass deposited is directly proportional to gram equivalent. Let us suppose the mass deposited for copper is X and for silver it is 54. Then I have written X by 54. This is proportional to equivalent weight of copper is 63.5 divided by 2 upon the gram equivalent weight of silver you are taking, 108, isn't it? So the value of mass deposited of copper comes out to be 63.5 divided by 4. You understand? 63.5. If you simplify this thing, you will be getting 63.5 upon 4. You can simplify this thing. This much gram of copper will be deposited. So essentially in this example, we have used this concept that mass deposited, in case the charge is same, then mass deposited is in proportion to the equivalent weight of the substance. In case in this question they had given you the value of Z, then directly you can calculate the amount of the charge which has flown into the circuit and all those things. And this much of calculation just involved this aspect that mass deposited was just proportional on gram equivalent weight. You should be happy that on this particular topic we cannot ask you too many difficult questions so long as physics is concerned. Only a simple application of M is equal to ZIT. So this is all in today's lecture. Now before we move ahead, let me summarize what all we discussed in today's lecture. In today's lecture, first we discussed thermoelectricity, in thermoelectricity we had to discuss three effects. One was Seebeck effect, next was Peltier effect, then it was Thomson effect, there were some basic terms used in Seebeck effect like what is neutral temperature, what is thermoelectric power, all those basic terminologies. There were two simple numericals on Seebeck effect, but in Peltier effect, Thomson effect, it was all those theoretical information that what is the meaning of Peltier coefficient, what is the meaning of Thomson coefficient and so on, and application of all these effects. And the second aspect we discussed, that was chemical effects of current, in which we had to discuss only the simple Faraday's law of electrolysis, the single formula we used in this electrolysis was M is equal to ZIT. So that is all in today's lecture, and simultaneously that brings you to the chapter also of current electricity. Thank you.